Now we'll continue the Sturm function and Sturm theorem. But before that, we need to explain something, and that is previously we have done Descartes' rule of sign, and Descartes' rule of sign does not give the exact number of real roots of an polynomial equation or algebraic equation, whereas the Sturm method, which will be discussed here, gives the exact number of roots as well as the position of the real roots of an equation with real coefficient. So here the first recall for Sturm method, that is Sturm method gives the exact number of real roots as well as the position of the real roots of an equation. The position of the real roots of an equation with real coefficient. Of an equation with real coefficient. So this is the main advantage of the Sturm function. If we use the Sturm function theorem or Sturm function, that means Sturm method, what we will see? We will see the exact number of real roots as well as the location of the real roots, the position of the real roots of an polynomial equation with real coefficient. But this was not the advantage in the Descartes' rule of sign. That's why Sturm function plays an important role always. Now we will think about what is exactly called the Sturm function. So our next recall about Sturm function. So what exactly mean by the Sturm function? Let fx be a polynomial with real coefficient. Fx equals to say a0 plus a1x plus dot 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 an x to the power n. This is a polynomial with real coefficient. That means all a0 an are real number, and f1x be its first derivatives. That means f1x equals to f dash x. Now what we will do, let the operation of finding the HCF, of finding the highest common factor of fx and f dash x be performed with following modification. So what is the modification? This is very, very important in the Sturm function. The modification is the sign of each remainder. The sign of each remainder is to be changed before it is used as the next divisor. It is used as the next divisor. And the sign of the last remainder and the sign of the last remainder is also to be changed. Is also to be changed. So that modified remainders we call it as f1x, f2x, f3x, and so on. So the modified remainder, the modified remainder, obviously with their sign changed, the remainder, that means modified remainder means remainder with their, that is the remainder with their sign changed are denoted by are denoted by f2x, f3x, if rx. Where r is less than n, less than equal n, and this f1x, this fx, f1x, that means f dash x, f2x, the remainder, the modified remainder, the remainder with sign changed, f3x, f4x. These remainders are called Sturm functions. Are called Sturm's functions. So now when we will solve the problem, we completely know what exactly Sturm function means. But before that, we will move to important theorem. And that theorem relating the position of the real roots of an equation. So the theorem is called, recall 3. This is called Sturm's theorem. So in this theorem, you will see two important parts. One part is all roots are equal. So here the first case is all roots unequal. This is case 1. And case 2, this is the equal roots. So actual Sturm's theorem is applicable for locating the position of real roots. This is for locating the position of real roots of an equation. That means it is basically used for location of roots. So for location of roots, we will use a Sturm function. I said there is two cases. One case is all roots are unequal, and another case is equal roots. So when all roots are unequal, in that case, let fx be a polynomial with real coefficient. Polynomial with real coefficients, and a comma b both are real number, be such that a less than b, then the number of real root of the equation, the number of real roots of the equation fx equals to 0 lying between a and b is equal to the excess of number of changes of sign, the number of changes of sign in the sequence of Sturm functions. In the sequence of Sturm functions fx, f1x, f(x), when x equals to a, over the number of changes of sign over the number of changes of sign in the sequence of Sturm function when x equals to b. So this is basically number of real roots of the equation lying between a and b, and this is called Sturm theorem when all roots are unequal. But when roots are equal, that means all roots are equal. So on that case, what will be the Sturm theorem? Let again fx be a polynomial with real coefficient, be a polynomial with real coefficients, and a comma b are real numbers with a less than b, then the number of real roots of the equation fx equals to 0 lying between a and b So here basically we are talking about a multiple root because roots are equal. If there be any, being counted once only, that is equal to the excess of the number of changes of sign, the excess of the number of changes of sign in the sequence of Sturm function. In the sequence of Sturm function, fx, f1x, f(x), when x equals to a, over the number of changes of sign changes of sign in the sequence. In the sequence when x equals to b. So these are the theorems, Sturm theorem, that we need to recall, and by using this theorem we can find out the position or the location of the roots. Now we come to one important problem that we will solve with the help of Sturm function. So Sturm function tells us two things. One is number of real roots, another thing is position of real roots. So two things we need to develop from Sturm function: the exact number of real roots, and the second thing is location of real roots, or you can say the position of real roots. Okay, so in that case the Sturm functions and theorem both will help us to determine these two things: what is the exact number of real roots and what should be the position of the real roots. That must be determined through the Sturm theorems and functions. Now we come to the problem. The first problem, the problem is very, very important. Find the number of and position of the real roots of the equation x cube plus 3x plus 1 equals to 0. So now we'll come to the solution, how to solve this kind of problem. So first you will write fx and f'(x) according to the Sturm functions rule. So here let fx equals to x cube plus 3x plus 1. Then f'(x) equals to 3x square plus 3. And from that, okay, we'll write, okay, first x cube, we'll solve this problem, x cube minus 3x. So that will be minus 3. So 3 into x square minus 1. So therefore, we will write f1x is basically f'(x), but okay, we will remove the factor, no problem. That will help us for calculation. So that will be x square minus 1, and right here removing the factor 3. So we can remove the factor, no problem. So this will be our f1x. Now we come to the f2x. How we will find out f2x? But before that, we need to find out the HCF of fx and f'(x) we need to perform. So first we will perform how to calculate the HCF of fx and f'(x). That we will do first, and then after that we will think about f2x, f3x, that modified remainder. So here is, we'll divide, find out the HCF of fx and f1x, or you can say f'(x). X square minus 1, x cube minus 3x plus 1. We take x here, so that means x cube minus x, so minus, that will be plus, that will be minus 2x plus 1. But what I said, our f2x will be the modified remainder. So the remainder is this. If we multiply this remainder by minus 1, it will be 2x minus 1. So this is the modified remainder. Now with the help of modified remainder, again we will divide x square minus 1. So what will happen here? X, that means first we multiply by 2. So this will be 2x square minus 2. So now if we multiply x by 2x minus 1, that will be 2x square minus x minus plus, it will be x minus 2. Again if we multiply by 2, so 2x minus 4. So plus 1, this will be 2x minus 1. So minus plus, it will be minus 3. So what will be next modified remainder? So what will be f3x? So what I said here, the last remainder is also to be changed. Sign of the last remainder is also to be changed. So here the sign is minus 3. So that will be changed and it will be minus or minus. That means it will be plus 3. So what will be our f2x and f1x, f3x? So here f2x will be 2x minus 1 and f3x is basically 3. So these are the Sturm function. So now we will write the Sturm function. So therefore the Sturm's functions are fx, this is basically x cube minus 3x plus 1. f1x, this is x square minus 1. Just here we remove the factor, no problem, you can or cannot remove the factor. What is f2x? This is the modified remainder, 2x minus 1. And f3x, the last remainder, the sign is also changed, it is basically 3. So these are the Sturm function. Now we will find out the nature of the roots, that means how many real root and complex root are present, and then we will find out the location of the roots. Now we come to the next point. So with the help of Sturm function, what we will deduce? We will deduce the nature of the roots. Nature of the roots. How we will do? We will prepare a table. So here x, then fx, write all the Sturm function, f1x, f2x, f3x, and here the changes of sign. So changes of sign means here we will apply the theorem here, the number of changes of sign, the sequence of Sturm function of fx, f1x, frx when x equals to a and x equals to b. But okay, here we are searching the real roots, 0, infinity and minus infinity. So first we will put minus infinity. If we put minus infinity, so what will be the sign of f? That will be negative. If we put minus infinity here, so f1x will be positive because square term is here. Odd degree of x, so that will be again negative. And f3x will be positive because it is already constant and positive. So how many changes of sign? Minus to plus 1 changes, plus to minus 1 changes, minus to plus again changes. So changes of sign is 3. Now come to 0. If we put 0, in the first case the fx is 1, that means positive. Second case 0 square minus, it will be minus 1. If f1 0 is minus 1, negative. Then f2 0 is also negative and f3x is positive. So how many changes of sign? Plus to minus, minus to minus, no changes. Minus to plus, again 1 changes. So 2 changes of sign are there. Now you will think about infinity. That is, if you put however large number, that represents plus infinity. So plus infinity, it is positive, again positive, again positive. So all are basically, there is no changes of sign. Okay. So if we think about the changes of sign, that means positive real roots, we will think about 0 to infinity. How many changes of sign variation, excess changes of sign. And if we think about the negative root, again we will think about how many excess changes of sign in minus infinity to 0. Okay. So that excess we need to determine, and according as we need to calculate. So here, if we, in that case, 0 to infinity, so here the excess change of sign is 2, and 0 minus infinity is 0, excess change of sign is 1. So that means the number of negative root is 1 and number of positive real roots is 2. That we need to calculate. So what we will write? The equation has, therefore our conclusion is, the equation x cube minus 3x plus 1 equals to 0 has 3 minus 2. So here you will see the exit changes of sign. This is 3 minus, that means 1 negative real root, and here you will see the positive side 0 to infinity, the excess change of sign is 2. So 2 minus 0, that means 2 positive real roots. So here the number of real roots is 3. Among them, 1 are negative real root and 2 is positive real root. So we will conclude, thus the given equation has 3 real roots. That means all roots are real, 1 negative and 2 positive. So this is our answer for the nature of roots. So in the question, there are 2 parts: number of roots, real root, or nature of real roots. And the second one is the position of the real roots. That we need to, this is the second part of the problem. So we will determine the position of real roots, or you can say location. Same language, location of real roots. So previously we observed positive root is 2 and negative root is 1. But in which position they lies, we are not determined. We just determined positive and negative. But we are not determined here the interval, in which interval they lies, that we need to perform here. Okay, so for location of roots, what we will do, we'll write first all the Sturm function in the table. That means fx, f1x, f2x and f3x. Okay, so you know your fx equals to x cube minus 3x plus 1. You know your f1x equals to x square minus 1. This is 2x minus 1 and this is basically 3. So I am writing here for just help. Now we will think about the changes of sign. Now the question is, in which way you will find out. So first you will think, okay, we'll start from 0. Starts from different x, so start from 0. So if we put 0 here, so what will be the value? The value is 1. So it is positive. 0 here, that will be negative. 0 here, again negative. and that will be positive. So how many changes of sign? 1. There is no changes. 2. So only 2 changes of sign. Plus to minus and minus to plus. Now we'll search the interval in which the positive roots and negative roots we come to forward 0 to say 1. We take 1 here. If we take 1, if we put 1 cube minus 3, so 1 minus 3 plus 1, that means 2 minus 3, so it will be minus 1, that means negative. If we put 1 here, so it will be 0. So 0 is just considered as omit. 0 has no sign. Then if we put 1 here, it will be positive. If we put 1 here, again it will be positive. So you just think about, you have 0 is just omit. So minus to plus is 1 changes. Plus to plus no changes. So only 1 change is there. So that means there is you will see the variation or changes of sign is basically changed. 2 and 1. So that means there is 2 minus 1. So 1 positive root. So 1 positive root lies between 0 and 1. Now we'll move again forward. Say we'll move to 2. Now you just put x equals to 2 here and you will see what is happening. If we put x equals to 2, it will be positive. Then if we put x equals to 2 here, also positive, positive, positive. If we put x equals to 2 in fx, f1x, f2x, f3, all are positive. So that means there is no changes of sign. Again you will see the excess changes of sign over x equals to 1 to x equals to 2. This is also 1 minus 0, 1. That means there is also one positive root. So we have positive root, one root between 0 to 1 and other root between 1 to 2. So now we will not search any, will not continue on the positive side because we have 2 positive root and that is already we searched. So we will not continue, but we are basically not moving forward to the positive side. So now we need to search one negative roots. So see if we put minus 1 and we will see what is happening here. So minus 1, if we put minus 1 here, so that means minus 1 whole cube, that will be positive. And here minus 1, that will be 0. Here minus 1, that will be negative. Here minus 1 positive. So just you omit 0. So plus to minus is 1 changes. Minus 2 plus 2. So there is no variation. So changes of sign over x equals to 0 to x equals to minus 1. No changes. Still it is 2. Now we come, that means there is no negative root. So here present, but there is no negative root. Now we come to the, next we will put the minus 2. So if we put minus 2, that will be negative. If we put minus 2 here, that will be positive. Minus 2 here, that will be negative and positive. So 1 change to plus to minus, minus 2. So 3 changes of sign. So here the excess changes of sign from x equals to minus 1 to x equals to minus 2. So this is 3 minus 2, that means 1. So that means one negative root is there. One negative root. So we are not continuing again on the negative side because we have one negative that we already searched. And 2 positive root that is already searched on positive side. Negative root already searched in negative. So we are not continuing now. So what do we get? We get actually 2 positive roots and 2 negative roots and its location. Okay. So now we will write one roots lies between. Therefore, what we will conclude? We conclude one root lies between minus 2 and minus 1. One lies between 0 and 1. And one lies between 1 and 2. So we have searched the location of roots also. So this is all about the Sturm functions and Sturm theorem that we have used here to find out the number of real roots, exact number of real roots, as well as the location of the real roots. Okay. So this kind of problem is very, very important. So now we come to one exercise problem. Exercise 5B, scheme of a book, classical algebra. So here the question is, question 2, calculate Sturm function. Calculate Sturm functions and locate the position of the real roots of the equation and locate the nature and position of the real roots of the equation. Locate the position of the real roots of the equation x cube minus 3x minus 1. Previously it was x cube plus 3x. X cube minus 3x plus 1 minus 1. Previously it was x cube minus 3x plus 1. Now it is given minus 3x minus 1. So this problem is also important. So how we will find out the exact number of real roots, Sturm functions, and with the help of Sturm theorem, how we will find out the position of the real roots. So here we come to the solution. First you write the fx, this is equals to x cube minus 3x minus 1. Now then f dash x, that will be 3x square minus 3. I said it will be helpful if we remove the factor. So what will be your f1x? F1x is exactly f dash x, but okay, we will remove the factor, so it will be easier for us. So f1x equals to x square minus 1 within bracket, removing the factor. Removing the factor from f dash x. It will be helpful. Now we come to the find out the HCF. We are trying to find out the HCF of fx and f dash x. Okay, we'll write f1x. So it is basically x square minus 1 and x cube minus 3x minus 1. In similar way, that will be x cube minus x. So minus plus, that will be minus 2x minus 1. So what will be our modified remainder? So our modified remainder is multiple the remainder with minus symbol. So that will be 2x plus 1. So now 2x plus 1, that will divide x square minus 1. So 2x square minus 2. So now we multiple, so that will be 2x square plus x. So minus minus, so minus x minus 2. So now if we multiple by 2, so minus 2x minus 4. So minus 1, so minus 2x minus 1. So plus plus. So this will be minus 3. Okay, but the last remainder is also, the sign will be changed. In minus 3 goes to the plus 3. So what are the Sturm function? And hence we can write f2x is basically 2x plus 1 and f3x equals to plus 3. So thus the Sturm functions are. Therefore the Sturm functions are fx equals to x cube minus 3x minus 1. f1x, this is x square minus 1, just removing the factor. f2x, these are the modified remainder. So this is basically 2x plus 1. and f3x basically 3. So these are the Sturm function. Now we'll find out the nature of the roots. Nature of the roots that we have also done in previous problem. So what we'll put x, fx, f1x, f2x, f3x, and he will write the changes of sign. We'll put 0 first. So 0, that will be negative, negative, positive, and here also positive. So here the number of changes of sign is 1. If we put infinity plus infinity, so that will be positive, 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 positive. So no changes of sign. If we put minus infinity, so negative, negative, positive, that will be negative, positive. So 1, 2, 3. So 3 changes of sign. So here the excess changes of sign is 3 minus 1. So this is 2. From x equals to, that means minus infinity to 0. So that means that is 2 negative real root. And if the excess changes of sign from 0 to 1, this is 1 minus 0, 1. That means 1 positive root. So equation degree is 3. 2 positive and 2 negative, 2 negative real root and 1 positive real root. So that means the equation has 3 real root. So therefore, our conclusion is the equation x cube minus 3x minus 1 equals to 0 has 3 real roots, 1 positive real root and 2 negative real root, negative real root. So that part is done, the nature of the roots. Now we come to the location of the roots. Okay. So now we will find out location of the roots. Okay, what we have done? We have done here 0, 1 positive root and 2 negative root. So 1 positive root and 2 negative root. So again we will make the table. So this is x, fx, f1x, f2x and f3x. Okay. So here f3x, first we put 0. If we put 0 here, so this will be negative. f1x again negative, f2x will be positive, that will be positive. Here changes of sign. Changes of sign. How many changes of sign? This is 1. So now we'll move to the forward. Say 1. If we put 1 here, if we put 1, so 1 cube, 1 minus 3 minus 1, so that will be negative. This will be 0. This will be 3. So that means positive. It is positive. Again positive. So just you omit 0. So minus 2 plus 1 changes of sign. So that means here you will observe. So the excess number of sign is 0. That means there is no root. So we need to continue. So now if we put 2. So what will happen if we put 2? 2 here, if we put, that will be positive. Because 8 minus 7, 1. If we 2, that will be positive. Here is also positive. Here is positive. So here you will see the excess number of signs. So 1 minus 0 is 1. So that means 1 positive root lies between 1 and 2. So we have one positive root that we have decided. Okay, it lies between 1 2. So we are not continuing on the positive side. Now we will come to the negative side. If we put -1, if we put -1, that will be positive. If we put -1 here, 0. -1 here, that will be negative, and that will be positive. So the number just you omit 0, plus 2 minus and minus 2. Oh, that means there is a excess variation of sign. So that means 2 minus 1, 1. So one root between 0 to -1, one negative root. Now we put -2. If we put -2, so that will be negative. If we put -2 here, it will be positive. Then -2 here, it will be negative. Then positive. See here 1, 2, 3. So there is also you will see the variation 3 minus 2. This is 1. That means one negative root between -1 and -2 and -1. So we have two negative root. We already searched it. That means we are not continuing in negative side further. So we got one positive root that lies between 1 and 2, and two negative root. One lies between 0 to -1 to 0 and -2 and -1. So what we conclude? So thus the negative real roots lies in the interval -1, 0 and -2, -1, and the positive real root lies in the interval 1, 2. So in that way you can solve the problem with the help of Sturm function and Sturm theorem. And what do you exactly find out? You find out the number of real roots, exact number of real roots, and how many are positives and how many are negatives. That means you can find out the nature of the real roots, and as well as you can find out the location of the root. That means where the roots exactly lies, in which interval on the positive real axis. That you must determine with the help of Sturm function and Sturm theorem. Now we come to the questions. If you have given the question, the number of real roots of the equation x cube minus 3x plus 1 equals to 0 is option A, no real root, option B, 1 real root, option C, 2 real root, and option D, 3 real root. So here we have seen in the first problem, okay, with the help of Sturm function, in that case all roots are real, and in fact we have seen in this problem, the first one, x cube minus 3x 1, we have seen the positive side, the excess changes of sign is 2, a negative side is 1, 2 positive real root and 1 negative real root, that we have decided with the help of Sturm function. So the number of real root is 3, all other options are false. If you have asked the number of positive real roots of x cube minus 3x plus 1 equals to 0 is option is 0, option B 1, option C 2, and option D 3. Here you have seen in that case the positive root is exactly 2 with the help of Sturm function, that we must decide. So number of positive root is 2 and all other options are false. So thank you so much. And again, maybe in the next class we'll continue more problem, we'll solve more problem.